Welcome. We have 5 major tricks in indices and logarithms that you want to discuss. So we shall be posing and having some example of questions for you to solve, as well as solving some online here. So remember, we have 5 of them. So the first one is conversion tricks. We want to see how do you convert from indices to logarithm and from logarithm to indices. For instance, if you have a number like a raised to b is equals to c, that is in indices form, so you can write it to be the logarithm of c to the base of a to be equals to b. So therefore, where is the trick? The trick is that it normally becomes the log of the answer that you're using under the indices, so it becomes the logarithm of c. Then the one that had been risen to, or the one that you can call the base, becomes now also the base here, so it becomes a, which is equals to the power that you're using here. This b is the power, so it becomes is equals to b. So therefore, in terms of numbers, so you can say if given a number like 2 raised to 3 is equals to 8, so it now becomes the logarithm of the answer, which is 8, then the base was 2, so is equals to the power that was 3. So you'll be done. The second trick is a trick on coefficient of logarithm. For instance, if you have a number like a log b to base c is equals to maybe d, so this is the coefficient of the logarithm. So this coefficient normally implies the power of this number that has a log, so that it becomes the log of b raised to a to base c is equals to d. So where is the trick? For example, you can be having a number like 4 log 5 to base 2 maybe is equals to 3, or you can say it's equals to x because you don't know the exact answer. So that one can be written as log. This is the coefficient before the log, so it becomes the power of this number. So it becomes log 5 raised to 4 to base 2 is equals to x. Therefore, that is our second trick. The third trick is a trick on addition and subtraction. So addition and subtraction of logarithm, where we say that where there is addition implies multiplication, while subtraction of logarithm implies division. For instance, if given a number like the log of a to base 2 plus the log of b to base 2 is equals to, so you want to solve, so we say that the first thing you're supposed to check and ensure that they have the same bases. Remember, you cannot add or subtract the one that has different bases. So to check, so this one is a base 2, so they can be added. So it becomes the log of brackets a is addition is multiplication, so a times b to the base of 2 because they had a common base, and that one becomes the log of ab to the base of 2. In the same way, you can as well be having the logarithm of a to base 2 then minus the logarithm of b to base 2. So again, you check the bases, so the bases are the same, so it becomes the logarithm of a divided by b to the base of 2, which is the same as the logarithm of a over b to the base of 2. Therefore, the trick is that addition implies multiplication, while subtraction implies division. In real sense, we can also use this example. So we have log 16 to base 2 plus log 8 to base 2 minus log 4 to base 2. So the first step is to confirm if they have the same bases. So this is log base 2, base 2, base 2. So they can therefore be added or subtracted. Then remember, under the BODMAS formula, we normally go for addition first, then subtraction comes last. So it becomes the logarithm of 16 times 8 to base 2, then divided by 4 to base 2 again. So this one can be simplified and get it to be the logarithm of, so this one from the calculator, 4 goes here 2, this one becomes 32. So the logarithm of 32 to base 2. Remember, from the conversion sign, this one is the same as what it implies. 2 raised to a certain number. 2 raised to a certain number will give you 32. So 2 raised to x will give you 32. So putting them under the same basis, it becomes 2 raised to x is equals to, this one can be written as 2 raised to 5. So therefore, x is equals to 5. So therefore, we can say that the logarithm of 32 to base 2 is the same as 5 from the symbol tricks. Trick number 4 is under the inverse of bases. You can say inverse of logarithm basis, logarithm or basis. So under this, you want to see how do you inverse or interchange the bases and the logs. Remember, we can have that logarithm of a to base b is equals to c. So this one can be interchanged and written as logarithm of a to base b is equals to the inverse of now the logarithm of. So you also interchange under the inverse, you also interchange this one. So this one goes down, this one becomes upper, so it becomes the logarithm of b to base a. So therefore, this trick only means that when you inverse the number or when write 1 over, it means that the logs becomes the base and the power or the inverse. In real sense, for example, we can say that the logarithm of 16 to base 2 can be written as the inverse of the logarithm of, now this one becomes 2 to base 16. Remember, we can also prove it by saying that 2 raised to x for this one, 2 raised to x is equals to 16. So 2 raised to x is equals to 16. That means here that 2 raised to x is equals to, this one can be written as 2 raised to 4. So therefore, x is equals to 4 when dropping the bases. Similarly here, we can say this is 1 over. So this is the inverse of now. So 16 raised to x is equals to 2. So therefore, this is like 2 raised to 4 is equals to 2. But remember, you have an inverse here that you have left, so you shall recur it later. This one becomes now 4x, 2 raised to 4x, so 4x is equals to 2. That means that x is equals to this 2 raised to 1. 2 is equals to 1. So therefore, x is equals to 1 over 4. Carrying this inverse that we left here, it now becomes that x is equals to 1 over 4 is still the same as 4. So therefore, this one and this one are the same. So it implies that this inverse has been confirmed to be a right trick. We can as well use this example. So if you have 2 log x to base 2, then plus log 2 to base x is equals to 3. So remember, we said for addition and subtraction to work, the bases are supposed to be the same. Here, we have base 2, here we have base x. Remember, x is a non-base, so you have now to find the inverse so that we interchange and have here maybe base 2, or another way out. So therefore, we are supposed to say that 2 log x to base 2, because this is a non-base, we maintain it, then it becomes plus now the inverse of this one. So when you inverse, you also interchange so that it becomes the log of x to base 2 is equals to 3. Under this, we now let log x to base 2 to be a number maybe y. So letting it to be y, we now replace where there is this number with y. So that we now end up with 2 here times y, then plus 1 over this one here is also y, so is equals to 3. Multiplying both sides by y to remove the denominator, so it gives you 2y squared plus 1 is equals to 3y. Collecting to form a quadratic equation gives you 2y squared minus 3y plus 1 is equals to 0. Remember, we can use quadratic equation that says y is equals to negative b plus or minus the square root of b squared minus 4ac, the whole of it divided by 2a, so that we are now using our negative b as negative 3, which gives us positive 3 plus or minus the square root of, out of the square root negative b squared is 3 squared, then minus 4 times our a here is 1, is 2 then times c, our c here is 1. The square root is all over is 2 times our a here is 2. That means you get 3 plus or minus 1 divided by 2. So meaning our y1 for the addition is 4 over 2, which is 1. Then our y2 for subtraction, that is 2 over 2, which is, this one gives you 2, then this one gives you 1. So therefore, we have two answers, that y is equals to 2 or y is equals to 1. Remember, we said here that the log of x to base 2 is the one that is y. So therefore, maybe solving it here, you can now say that log x to base 2, instead of writing y, we can write our y1, which is 2. So you say it is 2. So therefore, solving for x, it means 2 raised to a certain number will give you x. That is 2 raised to a certain number. 2 raised to a certain number, which is 2, will give you x. So therefore, 4 is equals to x. Remember, this one has just come from the first trick that we said a raised to b is equals to c can be written as the log of c, the base of a, is equals to b. Therefore, we are using this one as this one. So therefore, it becomes a raised to 2. This is 2 raised to 2 to give you x. Or you can still say that the logarithm of x to base 2 is the same as our y2, which is 1, is equals to 1. That means that 2 raised to 1 is equals to x. So that means that 2 is equals to x. So therefore, the value of x can either be 2 or the value of x can be 4. The fifth trick is a trick on squares. You can write squares of logarithm. For example, if you have a log of x to base 2 squared, then plus the log of x to base 2, so maybe is equals to a certain number, we can just say is equals to 2. So how do you solve that? It has a square. Whenever you see a logarithm having a square, you simply let it to be a certain number. So you can now say that let log x to base 2 be a certain number, for example, b. So we now say that b squared, remember you are replacing this one here, so it becomes b squared because of that above 2, then plus this one again becomes our b, so plus b is equals to 2. Remember, that one becomes b squared plus b minus 2 is equals to 0, which is also a quadratic equation. So therefore, that implies that b is equals to negative b plus or minus the square root of b squared minus 4ac all over it is over 2 times a. Replacing what we have, our negative b is negative. This one, so it becomes negative 1 plus or minus the square root of, this one is 1 squared minus 4 times 1 times negative 2 all over 2 times 1. That gives you negative 1 plus or minus this 1, this is 8. So 1 plus 8 is 9. The square root of 9 is 3, then over 2. That means our b1 is equals to, for addition, negative 1 plus 3, it becomes 2. So 2 over 2 is the same as 1. Or our b2 is for subtraction, negative 1 minus 3 is negative 4 over 2, which means negative 2. But remember, we said up there that log x to base 2 is equals to b. So we now come and write here that log x to base 2 is equals to b, but our b1 is 1. That means 2 raised to 1 is equals to x. So x is the same as 2. Or log of x to base 2 is equals to b, but our b2 is negative 2, so is equals to negative 2. That means 2 raised to negative 2 is equals to x. Remember, this is the same as 1 over 2 raised to 2 is equals to x. That means 1 over 4 is equals to x. So it's simple as that. Therefore, in summary, we have 5 tricks that are used. The first trick was for conversion trick from logarithm, where you say that a raised to b is equals to c is written as logarithm of the answer to the base of the base is equals to the power. The second trick is on the issue of addition and subtraction, where we say that addition in logarithm implies multiplication, subtraction in logarithm implies division. Then the third trick as well was on coefficient, where we say that coefficient, for example, 2 log 3 to base 2, in this case 2 is a power, so it is written as log 3 squared to base 2. So the coefficient implies the power. Then you also move to another trick which was about the inverse. The inverse, where we say that a log a to base b can be written as 1 over log b to base a, as well as the final trick. If you have any question on logarithm, you can simply drop it under the email provided at the profile